bank of cumulus clouds, a warm August afternoon.
For this cloud, it looks like it's sitting right over Combination, the old Combination.
This plane, operating from a weather research base in Montana, is about to perform an experiment on a cloud.
The only one of any consequence around. Its shadow is just now, looks like a shadow is over Site 5.
It used to be a shrewd observation that everybody talks about the weather, but nobody does anything about it. It's no longer true.
83 Charlie 8 Kuiper. The cloud appears to be over old town of Combination.
The plane is spreading a trail of invisible chemical smoke, billions of tiny particles of silver iodide produced by the burners under the wings. Air currents will sweep the particles up into a cloud where, if conditions are right, they will trigger the transformation of minute water droplets into crystals of ice. In the dry air of this afternoon, with a cloud as small as this one, the crystals are blown away by the wind like dust before a broom. The insubstantial pageant of the sky fades into thin air. We have learned a great deal about the atmosphere we live in. The camera, speeding up the movement in the sky above, reveals restless forces. Instruments tell us of jet streams of air, fierce winds circling the globe far above the clouds we see. We live at the bottom of a turbulent ocean of air, scores of miles deep. And what we see from below is just a small part of an atmosphere which is powered and driven into complex movement by the energies of the nearest star, 93 million miles away, the sun. Streaming out from the hub of the solar system are many different kinds of energies. Sometimes, when there are solar storms, its own gaseous substance is ejected into space as clouds of particles. And always, steadily, the sun pours forth light, heat, ultraviolet rays, radio waves. Almost all these forms of energy affect the atmosphere of our distant Earth. When clouds of solar particles stream toward our planet, some of them are caught in its magnetic field and form enormous nebulous envelopes, detectable only by instrument probes far out in space. Sometimes these particles are pulled in by the Earth's magnetic poles and meet with the tenuous topmost layers of the atmosphere, making it glow with the flickering light of the auroras we occasionally see 100 miles above us. Below the auroras, the Earth's thickening atmosphere becomes a shield under which human life can flourish. In this cushion of air, every day hundreds of tons of meteoric debris burn up by friction before reaching the Earth. And if we dropped from this altitude in a long arc down toward the Earth and had special powers of sight, we could see many different layers within our atmosphere protecting us from the harmful electromagnetic radiation of the sun. Layers that filter out the longer ultraviolet rays, that filter out X-rays, a layer of ozone, without which enough short-wave ultraviolet radiation would reach the Earth to destroy almost all life. Gradually, as we near the Earth's surface, The light from the sun is scattered by denser air and fine dust, turning blue the sky above us. Of all the energy the atmosphere receives from the sun on a clear day, about 2/3 gets through to shine on the lands and seas of Earth. The Earth, in turn, heats the air, and in heating it, stirs it into the tiny eddies and global patterns we call the weather. All creatures in time have learned to adapt somehow to the Earth's enormous range of heat and cold and wet and dry. Through clothing and shelter, we make our compromises with the weather, not always with success. It's not surprising that when humans meet, the first thing they talk about is the weather. The joy of a crisp and sparkling winter day. The inconvenience it sometimes causes us. Some remember catastrophes of weather and climate. The drought and winds in the 30s that turned parts of America into a dust bowl. Some have felt terror before an onrushing tornado. Many have cringed before the onslaught of a hurricane. This airplane is heading toward a hurricane. Its crew of weather technicians are members of the Hurricane Hunter Squadron of the U.S. Navy. Why should men fly into a hurricane? They go basically to measure its position and size, its pressures and winds, to relay back information that will enable weather forecasters to give accurate warnings. For the most immediate function of meteorology is to predict, to tell us tomorrow will be a lovely day for a picnic, to give advice that will save $1 million crop, to broadcast a warning that will save 1,000 lives. On the radar screen, the coming hurricane is seen as a twisting spiral driven by ferocious winds. Their mission, to break through the core of the storm to its center, the eye.
Okay, Steve, it looks like it's about 18 miles in diameter. The tops go up to 47,000. We're gonna have to punch right on through. I have no holes in the radar.
Roger.
The planes are sometimes structurally damaged during their missions. To date, only one crew has been lost.
Priority, Navy 6, in the eye at 1545 Zulu, position 1531 north, 5140 west, over.
The eye. a deceptively calm funnel of hot, dry air, wheeling clouds. Where will the storm go from here? To predict, the meteorologist must understand the processes and patterns in the atmosphere. Photographs taken by a satellite camera traveling 100 miles above the sea reveal the total pattern. Hurricane Debbie coming into view below, off the coast of Florida. But a great hurricane is only a small part of the constantly changing patterns formed by enormous energies in interplay in the atmosphere. After passing the outer rim of the hurricane, only a few minutes by space camera, moist tropical air moving over a vast, cool ocean current is producing a solid white bank of cloud and fog. It extends all the way to the coast of Africa, and then clear skies over Morocco. At ground level, sizzling heat. Atmospheric scientists are gaining a more precise understanding of the causes of these phenomena. Here, for example, they are artificially creating global weather patterns for study. What they call familiarly the dishpan is a flattened model of the northern hemisphere. Ice is placed in the center core to simulate the pole. The heated outer rim is the equator. When dye is dropped into the water between and the pan rotated as our Earth rotates, patterns emerge. These patterns are like the vast currents in the Earth's atmosphere, which carry heat from the equator toward the poles and bring back cool air toward the equator. Without this constant heat exchange, the tropics would become unbearably hot, the polar regions unendurably cold. These currents moving between hot and cold form lobes, like the petals on a flower. And if we look at the rotating pan from above, through a camera turning at the same rate, we see a shape astonishingly like the patterns on a weather map of the northern hemisphere. It is possible to make another kind of model of global circulation.
So we take the kinematics of the motion completely into account, but between two zonal walls.
At the U.S. Weather Bureau in Washington and elsewhere,
The width
scientists are developing mathematical analyses of the weather.
where this is the heat flux through the mean meridional circulation. Flux that
The
way.
equations are put in a form that can be handled by a computer. Digesting millions of bits of weather information from all over the hemisphere, Point Barrow, Halifax, Baghdad, Manila, the computer calculates a prediction. The mathematical prediction of weather is now routine. The contours printed out by the computer are translated into the familiar wavy lines and bulges we see in the daily weather map. As men have come to a deeper understanding of the forces of the atmosphere, it was inevitable that some should dream of changing it. An infinitesimal bit of the atmosphere in one experiment, a few thousand cubic feet of condensed vapor from a geyser in Yellowstone Park. Temperature 20 below zero. They have suspended in the geyser cloud a balloon supporting a string impregnated with a special explosive. The countless droplets of moisture have been transformed into minute, glittering ice crystals. On this morning, they have created a halo around the sun. Investigating the detailed nature of such processes is the prelude to the possible control of some of the harmful aspects of the weather. The time may soon come when men will be able to say, yesterday we prevented a hailstorm. Today we stopped the lightning. By means of cloud seeding, atmospheric scientists are trying to find out if rain can be brought on prematurely in the clouds of a threatening thunderstorm. If it can, it might also be possible to reduce the destructive lightning discharges at the height of the storm.
Would you stay on the field, please? Give us a field reading. We have personnel wandering around outside. Over.
The field is now approaching 100 volts per centimeter. All personnel should be warned to be under the lightning protection system from now on for the storm. Over.
Roger. Personnel coming inside under protection. Over.
Must be getting in closer. We're starting to get some appreciable strikes. There was a good one.
Right at 285 feet. Ground discharge observed. Azimuth 243 degrees. This side of Black Pine Ridge. Flare up at base. Start that one, please. Over.
Skyfire aircraft 83 Charlie. This is. You know, if I were you, I think I would come down. Over.
Records are kept of the frequency and types of lightning strokes, of seeded and unseeded storms. Statistical analysis will tell if any significant modification has taken place.
89, that was a big one.
Record, this is control. We need to make an adjustment on our RHI video. Can you give us a field reading, please? Over.
Field rating is now 30 volts per centimeter. Rising. Is rising. Is safe for limited activity in the area.
Okay, Bill, go ahead. Roger, limited activity. He's going out to adjust now.
Control, field is rising very rapidly, approaching 100 volts per centimeter. Suggest all personnel be under cover.
Hurry up, Bill. He's building again. Roger, he's on his way back in. Here he is.
Visual strike at coordinates 335. Very close to site 1. Over.
Roger, we felt it.
Oh, that last one was a big one.
Snow and ice research in the Antarctic, air pollution work in England, arid climate research in Africa. The atmosphere is being studied all over the world, and we are gradually learning the true nature of the forces which surround us. As men continue to explore space, they may find no treasure anywhere like their own earthly environment, their atmosphere, their earthly weather, or a more beautiful, complex, and fascinating interplay of natural phenomena.